All right, welcome to another episode of Coding with Noah. My name is Noah, and today we're going to be hooking up an RGB LED to the Arduino Uno. We'll be building a website to control an RGB LED via the Arduino Uno, and this is using a new feature in Chrome called Navigator Serial that allows you to communicate directly to USB devices from Chrome. You do have to turn on a flag to use it. I'm going to demo it right now. I'm going to click on my USB icon. I'll click pair and connect, and I'm connected. And now I'm going to change the color of the RGB LED. So I'm going to select red, and I'm going to click change color. You can see it changes it to a red. It's not perfect. It doesn't perfectly match it. This is blue. Blue is a little bit easier to see. And then we'll do green. And you can see green. So yeah. So that's the demo. If you have any questions throughout the video, let me know. I'll be answering them in the comment section. I'll also have links to this website, which is publicly available. So if you just want to build the Arduino code, you can do that. And I'll also have a link to the Arduino code. So if you just want to build the website part, you can do that as well. Let me know what you think and throughout these sections, and I'll catch you in the video. So to get started, you're going to need 4 jumper wires, 1 RGB LED, 3 150 ohm resistors, 1 Arduino Uno, 1 USB cable to hook up the Arduino Uno to your computer, and a breadboard. So the RGB LED has 4 wires: a red wire, ground, green, and blue. Each wire controls a respective color. So the red wire will control the red color, the green wire will control the green color, and the blue wire will control the blue color. The longest wire is ground. So you know the one next to the end, the very end, would be the red, green, and blue. So that's how I remember it. So when you're plugging this into the breadboard, just be sure you remember which one is ground, because from there you'll be able to determine the red, the green, and the blue wire. All right, so I have my Tinkercad up, and this is just a diagram of the wiring. One thing to note is that we're using 150 ohm resistors between each color wire. So you can see that right here. The other thing to note is that each of the colored wires, so the red, the green, and the blue, are plugged into a PWM. So you can see PWM, and it has this little squiggly line right here. And PWM wires or pins can send a signal or a number to the RGB LED. So that's why we have to use them. They don't just go on and off, so they can actually send something in between on and off that can be interpreted as a number. The other thing to note is that the ground wire right here is getting plugged into ground of the Arduino. So that doesn't need a resistor. The other thing is that there's a little bit of a bug in Tinkercad, in my opinion. They have blue-green, and it should be green-blue, so you can ignore that. But this is the basic wiring. I'll have pictures of the wiring on my blog, along with step-by-step instructions where you can see it being wired each step of the way. But if this is good enough for you, you can go ahead and wire everything up. And if you have any questions, please let me know in the comments. All right, let's get coding. So the first thing we're going to do is we're going to open up the Arduino IDE. So I have it open. I'm going to pull up the screen. Just to let you know, I have my font set to 24 and I have display line numbers on. So you just check display line numbers and you can set your font to 24 if you want to follow me exactly, and you click OK. So the first thing I want to do is I want to define some constants, and constants are just values that the computer stores that don't change. So the first constant I'm going to define is red pin, and this will be 3. Then I'm going to define blue pin, and that will be 9. And then I'm going to define, oops, that's not blue pin, that's green pin, I'm sorry. And then I'm going to define blue pin, and that will be 10. Next, we're going to set up our pin mode, and that determines whether the pin is an input or an output. So we're going to put in red pin, which will store the value of 9, and we're going to say output. And these are all going to be output, so I'm just going to copy and paste. So now I'm going to say green pin and blue pin. Then I'm going to save, and this is very important. I'm going to say RGB LED web. So I'm going to save it as that, but you can save it as whatever file you want. So now that we have our pin mode set, the next thing I'm going to do is I'm going to create a function to change the color. So this function is not going to return anything, so I'm going to type in void. Then I'm going to type in the name of the function, which is change color. And then I'm going to type in int, which stands for number, and then red. So this will be the amount of red that we're going to put into the color. Then I'm going to type in int green, and this will be the amount of green that we put in the color. And then int blue, which will be the amount of blue that we put in the color. So then I'm going to use analog write, which will send a number to that pin. So I'm going to say the pin number, which is red pin, and then we're going to put in red. And I'm going to do the same thing for the others. Green pin, which will be green. And then you get the idea, which will be blue. So now I'm going to hit enter a bunch so you can see this a little better. So the first thing we want to do is we just want to test to make sure everything's working. So I'm just going to say change color, and then I'm going to say 255.00, and then we're going to do a delay of 2 seconds. And then we're going to do the same thing for green and blue, and I like to do this just to make sure that all of my pins are working. So we'll do 0, 255, 0, 255. So I'm going to save that, and I'm going to upload it. But before I do, I want to make sure that my board is selected, and it is, so that's good. And that I'm using the Arduino Uno, which I am. So that's good. So just to recap, we've set all the pins to output, the red pin, the green pin, and the blue pin. And we have this function that will change the color of our RGB LED using the analog write function, which will send a number, or the number of each color we want, to each of the pins that we want. So let's upload this. And it looks like it's working. So one quick note or thing that you can do is you can Google RGB color picker. So I'm going to do that right now, RGB color picker. And you can select any color you want. So I'm going to select a purple color. I'm going to copy that purple color in the RGB section. And then I can just paste this into here, and it will display that color. So if I were to upload this, it would do a purple color, which you can see right now. It goes back to green, and then it goes back to blue. Okay, just wanted to mention that. Okay, so now that we know that the wires are hooked up correctly and that we can change the color, let's get the code working to where we can send a message from the computer to the Arduino to change the color. So the first thing we're going to do that is we're going to say serial.begin, and that will allow the Arduino to receive messages from the computer. And we're going to set it to 15200, and that's the number of bytes that the Arduino, bits that the Arduino can receive every second. The next thing we're going to do is we're going to do serial.setTimeout, and this is so important. Otherwise, you're going to get a lot of bugs. And what this means is that the Arduino will wait 10 milliseconds for a message to be completed. If you don't set this, you'll get weird timeout errors and just everything will stall. So be sure to set this as well. So I'm just going to put a comment, number of bits the Arduino can receive per second. And then this is how long the Arduino will wait for a message, and it's 10 milliseconds. And this is 100, 15 bits per second. Okay, so the next thing we want to do is we want to comment this out because we want to test out it receiving a message. So we're just going to comment that out because we don't want all those delays, because that'll just pause the Arduino. Next thing we're going to do is we're going to create a variable called USB text, and this will be the text coming from the computer, or we'll call it computer text. That'll be easier to remember. Computer text. So this will be the text coming from the computer to the Arduino. So what we're going to do is we're going to say serial dot read until string, or read string until, and then we're going to put in the @ sign because everyone knows where the @ sign is. So this will read the string until it sees an @ sign. So the next thing we're going to do is we're going to trim the text because we don't want nonsense. So we're going to say .trim, and that'll just remove any weird white space. And then we're going to see if the computer text .length, which is a function measuring how long the text is that's being stored in the computer text variable. So we're going to say if it's greater than 0, and just to test this out, we're going to say serial.println computer text. So this means that if we see something being printed to our serial monitor, that means that we've received some message. So I'm going to save that, and I'm going to upload it. And it's uploading, and I can just test this without even showing the Arduino, which is cool. So I'm going to move my serial monitor in. Notice my baud rate is set to that large number right there, and I have timestamps as well. So I'm going to say text, and I'm going to use the @ sign, and you can see it just prints out text. So let's do word with the @ sign, and you can see it prints out word. If I do this with some spaces, the @ sign, prints out everything but the @ sign. So that's working really well. So the next thing we need to do, and I'm going to click clear output so we can see things a little bit clearly, is we need to parse the string. So we need to turn the string essentially into a list. So what that really means is we're going to send a string, something like this, to the Arduino. So it'll be like 92, 0, and maybe 130. So the 92 will represent the red value, the 0 will represent the green value, and the 130 will represent the blue value. So this would be like a purple color. So we want to send this text to the Arduino, but we want to have a way of accessing each of these values. So what we would want to do is we want to turn this essentially into a list. But that's a little hard in the world of the Arduino. But thankfully somebody on Stack Overflow, and I'll share this post in the link, created a function called getValue that does exactly this. So we're going to copy this, and notice that if they put in 2, print will print the is, because everything's indexed by 0. So when you're using this function, it starts at 0 and then starts counting at 0. So it'll be 0, 1, 2, 3. And you'll see this a little bit more in the code, so it'll make a little bit more sense. But I'm going to copy this and then paste this in right here. And the other thing to note is that this function returns a string, which is really nice. Okay. So, and that's important too, because we want to, we don't want to send a string. We actually want to send a number. So that's important as well. So the first thing we're going to do is we're going to just say if it equals 0, we're just going to return. So that way we don't have to do everything inside the if statement. We can do everything outside the if statement because we only care if it returns 0. So that's looking good. Or if it's greater than 0, if the text length is greater than 0. So the next thing we're going to do is we're going to create our color value. So we're going to say int red color, and we're going to set that equal to the getValue function. And then we're going to say our string data, which is our computer text, the character that we're going to use, which is this dash and the index, which is going to be 0. So in our example, which we'll put right here, actually we'll put it right here. Let me 92, 0, 130. We want the 92. So it would start at 0, 1, 2. So now we're going to do green color. And we're going to say get value. That's going to be computer text. And 1. And then we're going to say blue color. We're going to do the same thing. So that will get 130 in our example. Be sure you type everything out right. If you don't, something bad might happen. But it's okay. People make mistakes. Everyone's making mistakes. I'm making tons of mistakes making these videos. Believe me. So now we just want to pass in our color values. So we want to say red color, green color, blue color. And I'm just going to add a very small delay of 20 milliseconds, just so that we don't get overrun. Actually, I'll do 50 milliseconds. So I'm going to save that. I'm going to upload it. Oops, and we have an error. Let's see what our error is. Could not convert string to int. Okay, so this is something we forgot. So we do want these to be int values, but the string has a really handy property, toInt. So we forgot to put toInt all this. So toInt. And that'll convert the string to a number. So like I said, everyone's making mistakes. It's not a big deal. So now it's uploading. So it converted the string to an integer. And then if we use our serial monitor like so, and I'm going to type in 92. So I'll type in our example, -0, -130, and then we have to send the @ sign so it knows when to stop. And that did turn it purple. All right, so now we're going to create our website for controlling the RGB LED. We're going to be using Chrome Serial, which is an experimental feature of the Chrome web browser. To turn that on, we're going to need to type in Chrome://flags. And you're going to look for experimental web platform features. So you can just type that in here and it'll filter it out. And you're going to check enabled. And this will have you restart the web browser, just to warn you. So you'll have to restart it. I already have mine enabled, so I don't have to do that. The other thing you're going to need before you get started is live server. That'll just give us a server to serve up the web page. So go ahead and install that in. You'll just click on that icon on Visual Code and you'll type in live server. So that's pretty easy to do, and you'll just click on install. I've already installed it. Okay, so now that we've got that little bit out of the way, let's get started. First thing we're going to do is we're going to create a new file called index.html, and we're going to create our HTML5 template. So I'm going to type in, right here, RGB LED website. And I'm going to go ahead and open this up in live server. So I'm going to say open with live server, and you can see the titles right there. So now I'm going to create an H1. I'm going to say RGB LED website, like so, and you can see it's right there. I didn't like the default web browser font, so I'm using Font Awesome. I'm going to be using this font instead, this Business New font. You can use whichever font you like, obviously. So I'm also going to do a title here. I'm going to do a style tag here. So it'll all just be on one code file. So it'll be a little bit easier to see. And I'm going to put this font for the whole body. So now we can see that right there. For the H1 tag, I'm going to do a font size of 40 pixels. And I'm going to do text align center. And that looks a little better. So the next thing we need to do is we need to do an input of that's color that has a hashtag or an ID of color picker. And we can just get rid of the name because we don't need a form. And then for the input, and I'll scroll this up a little bit so it's easier to read. For the input, we're just going to say text align center, and oops, we don't need text align center. Let's actually, sorry, I'm having a brain fart. Let's display block, so it'll be like a block element, and then we'll do margin 20 pixels top and bottom, and auto left and right. So that's our color picker, so that's looking good. Next thing we'll do is we'll do a section with a ID of controls, and we'll do 2 buttons, and we'll do a button for connect USB. And I'm going to use the Font Awesome icons. I'm kind of using an older Font Awesome 4.7, but you can use whichever Font Awesome you want. So I'm going to copy this style tag, or this link tag, to link to the style sheet. So I've got my Font Awesome CDN, and I'll have links to all this. And then I'm going to use the USB icon right here to connect to the USB. And let's see what that looks like. It looks okay. So the next thing I'm going to do is we're going to have a button to change the color. So let's see what Font Awesome icon we can use. Let's see if there's like a change one. Nope. Oh, well, that's cool. We'll just do a text instead. So we'll just do text, change color, and we'll just change the ID to change color, because that'll be easy. I need to overthink this. So we got our USB icon, we got our change color button, and then we'll have a yeah, that should do it. I think that's all we need for this. So let's center these buttons. So we'll do section, and I think if we just do text align center, it should center them. So that's looking good. So the first thing we want to do is we want to have a script tag to where we can start writing some JavaScript in here. So I'm going to create a script tag. I'll move this up a little bit, and we want to create a function that will connect our RGB LED to the website. Basically connect the website to the Arduino. So there's an inaccuracy in this documentation. I'm sure they're going to fix it, but when we're using this filter, and this baud rate's inaccurate too, it should be lowercase r, but some of this documentation isn't perfect, so this is all subject to change, just to warn you. So we're going to do function connect, we'll say on connect USB, and we're just going to create a variable called is connected, and this will be true if the USB is connected. And that's looking good. So the first thing we're going to do is we're going to say, we're going to do a try and a catch, because we're going to be using promises. So that's important as well. So we need to mark this function as async, and this will happen, this catch statement will happen if the user decides not to handle select a port. So you really want this try catch here. It's not just for show. Okay, so the first thing we're going to do is we're going to copy this and this from the spec, and we're just going to make a few changes. So this is for the Arduino Uno. This is the vendor ID, but the change is we have to use USB vendor ID. So that should work now, and what you can see is we're just, and I'll put this on another line so you can see it a little better, we're requesting the port. So this will just be the port. So we'll get this access to this port if the user requests it. If the user doesn't, we'll console.log an error, and you can see what happens. So I'll show you what happens if the user doesn't select a port and what happens if the user does. But before we do that, we need to hook up our button to our on-click event to our button. So we're just going to say on connect USB. Okay, so that should connect it, and you can see we have it filtered. So we're only getting Arduino Uno. Let me just show you what happens if we don't filter. So I think filtering actually makes your app a little bit more secure because you only connect to what you want to connect. But you can see I get a whole bunch of stuff if I don't filter. So you really want to filter. So I only want to connect to Arduino Uno. And if I don't select it, you should see like a bunch of errors here. So if I don't select it, so I'm going to click cancel. You see error, no port selected. So that's why you want that try catch. Otherwise, your code might blow up. Okay, so we have our port, which is pretty cool. Next comes, if we look at the documentation, which is right here. I'll move this a little bit in. Comes our baud rate. Now this isn't, like I said, this is a lowercase r, so we're going to do a lowercase r, but the baud rate ironically is right. So that's the baud rate we used in the Arduino code. So it's the same. Baud rate just means the number of bits it can send per second. So your Arduino code has to match your website code, which makes sense. So we have our port, we're opening our port, and now what we want to do is actually create a port variable because we're going to need this port in another function. So we're going to make it a global variable. So we're just going to say port equals that. And then we'll say is connected equals true. And let's just make sure all that works. So we'll go back to our website, we'll click connect, and it looks like it's failed to open. Required member baud rate. Maybe baud rate is capital R. Let's try it with capital R. I might have gotten that one wrong. Baud rate is required. Give me a second. I'm gonna look into this. So something weird was going on. I'm not sure what it is, but I did unplug and replug the Arduino and refresh the web browser. So you might have to do that. But now when I click the button, I click this and I click connect, it does work. And I got this little icon right here. So what we want to do is what we want to happen is like when we click this change color button, we want to just send a message from the website to the Arduino, telling the Arduino to change whatever color has been selected. So what we're going to do is we're going to create a function, and this is going to be an async function. We're just going to call it change color, or we'll call it on change color because it's an event. And what we'll do is we will say const color equals, so we're going to get the color element, and the ID of that element is color picker. Makes sense. And then we're going to get the value of that element, which will be a hash value. So I'm going to say console.log. It will be like a, you'll see what I mean. So now when I click this, oh, forgot to hook it up. Made another mistake. So on click and then on change color. So that'll hook it up now. So now that when I click, you can see we get that. But if I were to change the color to something like this, you can see we get that. So you can see we get this hash color value. So what we want to do is Google, it's really a hex color to RGB JavaScript. And we just want to find a function that will convert it. And it looks like there's a good one right here. So this is, let's see, converting the other way, hex to RGB. This one looks really good. So we'll just copy this function. And I'll have a link to this on Stack Overflow. And what this will do is uses a regular expression, and it will basically turn this hex value into an RGB. So that looks good. So now we can say const. So we'll call this color hex. We'll say const color RGB, and we'll just use the function hex to RGB and put in our color hex. So now we'll get an object that has RGB in it. So that's good. So the next thing we need to do is we need to get our string ready to send to the USB. So we'll say computer text, just because that's what we used before. And I'm going to use these backticks because they allow me to do put in variables. So I'm going to say color RGB dot R dash color RGB. You can kind of guess dash G and then dash again and color RGB. Oops, it's not a dash, it's a dot. You guys are probably yelling at me. Dash B, and then we want to use the @ sign because that's when we know it's ended. So we've got our color text right here, and I'll make this a little bit bigger so you can see the whole thing. Okay, so that's looking good. Next, we're going to need to encode the text and a bunch of other stuff. So let's get started on that. So we're going to say, actually, yeah. So we're going to need a writer for this. So we don't want to do, we only want to get the writer once. So we'll do that up here. So we'll say let writer so that we have the writer. And we're going to say port dot writer. I think it's port dot writer. So let's do a debugger just so we can see it. So I can see. Okay, so we've got the port. Oh, it's writable. So I think it's port. Let's see, port dot writable dot get writer. That's what it is. So that's what we need to put in. So that looks good. So this will get our basically get the object that we need to write to the serial port. And the other thing we're going to need is a text encoder. So we're going to say const encode equals new text encoder. So this will encode the text, or basically allow us to use the writer. So now that we have our string, what we can do is we can say writer dot write, and then it's pretty easy. Encode, and oh yeah, so it returns an array of, that's what it's doing, text. So there we go. And I think this is a thing. Okay. So now when we click this change color button, it should write out the text and it should control the RGB. So I'm going to pick a color that'll work well with the RGB, purple, and then I'm going to click change, and I got an error, cannot read write of undefined, and that's because I did not hook it in, and this is also funny, we didn't check to make sure that the port was connected. So let's do that. So we'll say if is connected is false, we just return. And we'll even alert something. Alert, you must connect to the USB in order to use this. Okay. So that looks good. So let's try that again. Hopefully we'll get the alert. That's good. One thing I forgot to do before we do the demo is wrap everything in a try catch. So let's just do that really quick. Anytime you're dealing with promises, you should wrap everything in a try catch. I'm not always good about it, but you just want to do that like that. So that way if this blows up, it doesn't destroy the whole code and the user can restart. And we'll just console.log an error, and we'll alert could not write color. Now you could come up with a fancier error message for sure. So that looks good. So with that, I think we're ready to do our final demo. I'll be holding up the cell phone camera, so it might be a little messy, but it should be a lot of fun. So I'll catch you there. All right, just to make this a little bit easier, I've already connected the USB to the computer, so the Arduino is already connected. So I'm going to start recording on my cell phone right now. See if I can press that button. All right, so now I'm recording, and the first color I'm going to pick is red. So now I'm going to click change, and you can see it goes red. And now we're going to do blue. Do a blue color. You can see it goes blue. And let's do a green. And you can see it goes green. It's a little too bright for green. One thing we can do is we can try like a purple color. Purple usually shows up well in my experience. So we'll try purple. And it's purple. But it's hard to tell with this because it's so bright. Let me see if I can tone it down. There we go. Well, it's still kind of hard to see, but yeah, it is purple. Anyway, that's how you build an RGB color picker. And that's the project. So if you have any questions, please let me know, and I will catch you on the flip side.